Yeah, a very good evening to everyone. We warmly invite you all to the day 3 of the AICTE Training and Learning ATAL sponsored faculty development program on Joy of AI in Action, applying traditional and agentic AI to real world problems, scheduled to be held online from August 18th to August 23rd, 2025. We are truly honored to welcome our today's speaker, Dr. Love Kumar sir, to the third day of our ATAL FDP program. Dr. Love Kumar sir is currently working as an assistant professor in the Department of Computer Science and Engineering, NIT Kurukshetra. He received his PhD in Computer Science and Engineering from NIT Rourkela, Odisha, India. Under the supervision of Professor S.K. Rath, his current research interests are in the area of mining software repositories, software analytics, and social media analytics. His thesis is titled Predicting Software Quality Parameters Using Artificial Intelligence Techniques and Source Code Metrics. He worked as a faculty member at Thapar University from August 2017 to December 2017 and BITS Pilani from January 2018 to January 2023. He has delivered over 60 invited talks, over 100 international referred publications in international conferences and journals, and 4 published book chapters to his credit. He has won several other awards, including the Young Scientist Award, Best Researcher Award, and Best Paper Award. He has a broad range of interests and hobbies. He loves to play cricket, read books, play chess, and solve Sudoku puzzles. Thank you, sir, for accepting our invitation. Over to you, sir.
Okay, thank you, ma'am. Thank you. So first I'm going to share my screen. Okay, so I hope my screen is visible to everyone.
Yes, sir, it's visible, sir.
Oh. Okay, thank you. So good evening, everyone. So in this session, basically we will discuss about the generative AI, and parallelly we will also write the code how you can use the generative AI for your domain. If you are working in the area of text mining, then we can use the concept of generative AI. Parallelly, you can also use for some other applications. So we will see some example here. And for this session, we are going to discuss about the sentiment analysis. That is the common one, but the same code you can apply for any data. If you are working related to the text mining, then you can easily apply the same code. So first we'll go with the traditional method, then we'll go with the deep learning, and after that we'll go for the generative AI. Then you will know the benefit of using generative AI. For generative AI, we are planning to use the two different types of tool. We will use the Gemini for Google, and we will also use the Open AI. We will also use the Open AI. So we will see in which case we are getting the better result. And parallelly, we will also discuss about the LangChain. LangChain, if you are planning to develop any type of simple application, then you can also use the LangChain. Okay. After that, the time left, then we'll also go for the RAG model. Okay. So how we can develop the RAG model. So these are the outlines for the session. I will not take too much time in explaining the theoretical part. So I think you are very much familiar with these concepts. I will take 5 to 6 minute time only to explain the machine learning. And after that, directly I will jump to the NLP. Okay. And we will discuss what are the challenges, how we have started from basic and how we are going for the generative AI. Then we'll also discuss about the word embedding. We'll go for the generative AI. What is generative AI? What are the different types of generative AI that we'll discuss? And then we'll close the session. So if you're talking about the trends, nowadays, if you're going to talk about the trends of the machine learning, in every domain we are using the machine learning, not only for computer science related area, but even in the hardware related area, we are also using the concept of machine learning. Because if you are looking for automation, then definitely we can use the concept of machine learning. Because without automation, without machine learning, it is not possible to do any type of automation. Because whatever the decision you are going to take, that we are taking based on the concept of machine learning. So that's why the trends of the machine learning expert day by day it is going high. And even if you are going to check, the many college have opened the new department in AI and machine learning. So if you're talking about why the companies are moving towards the machine learning, what are the benefits they are getting, then these are the 4 motivation for every company they are moving towards machine learning. Even if you are talking about the software company, most of the codes they are generating by using this LLM. So even if you are going for the Microsoft, if you are going for the Google, Flipkart, then in this case, whatever the requirement they are getting, most of the code they are generating based on the LLM. And even the 10,000 line of code they are generating within an hour, that is not possible for any expert to write within an hour. If you are going to ask any expert or any developer to write 10,000 line of code, at least they are taking 2 to 3 month time to write the those code. And the same code the LLM is generating within a 10 to 15 minutes or maximum within an hour, they are generating the whole 10,000 line of code. So here, if you are going to check, these are the four main motivation behind every company that is moving toward the machine learning. The first one, if they are going to automate the procedure, okay. If they are doing the same task, as for example, the same thing like that, developer is regularly writing the programming, and if they are doing the same task, and if they are going to automate those tasks, then they have to use the concept of machine learning. So first one, if they are planning to automate the procedure, repetitive procedure, then they can use it. Next one, it also help to improve the efficiency, because as we know, this is just like machine learning is same like your machine, and the machine can work for any time. It can work for 24 into 7 time. That is not possible for any human to work. So definitely the efficiency will also improve. Next one, it also enhance the decision making, because as a human we can only try to find some simple pattern. We are not ready to find some complex pattern, or we are not able to find some extraordinary pattern that is completely different, or you can also call it as a hidden pattern. But if you are using the machine learning and if you are giving the data, it will try to find some hidden pattern. And after that, it also help to reduce the error. It also help to reduce the error. So these are the four motivation behind every company that is moving towards the machine learning. And the next one, the more important point, whatever the solution they are designing for one domain, the same solution they can also use for other domain by only changing the data. Means the code remains same, only we have to change the data, and it will start working for the new application. As for example, simple, I'm giving one example. I'm giving one simple example how it will work for the same data. So just I'm giving one simple example. This is just like as a human learning, how the humans are working. The similar way the machine learning will also work. So as for example, I'm giving one simple example. Simple example. These are the code I have written, little bit code. I will explain you later what is the meaning of this one. Okay, because normally it will take time to download the file. So initially I have written, I'm going to share this code with you also. So as for example, simple example, if I'm going to take simple example, if the value of a equal to 1, 2, 3, 4, 5, this is just like a pattern. Can you predict what is the next number we will get? The next number, we can easily predict the next number equal to 6. We can easily predict, because the pattern is we are getting the pattern 1, 2, 3, 4, 5, and then we are going to predict. The same thing if I am going to change the pattern. Now I'm going to give you 2, 4, 6, 8. Can you predict the next number? Again, we can predict the next number equal to 10. Now you can see, previous case we are predicting the next number equal to 6, and this case we are predicting the next number equal to 10. How we are finding those value? Based on these patterns, based on our experience, based on the data we are finding what is the logic behind the next number, and we are simply getting the logic is like that. If you are going to add +1, the next number will get. Same like that in the second one, if you are going to add 2, you will get the next number. Now the same thing if I'm going to write in the terms of programming language. So how we can write? So as for example, we are writing, this is the input we are giving. What is the input we are giving? The first two numbers we are giving, first three number, 1, 2, 3. Then the input we are giving 2, 3, 4. Then the input we are giving 3, 4, 5. We are also giving some more input, 4, 5, 6. We are also giving one more input like that, 10, 11, and 12. What is the output we will get for this one? If you are going to check what is the output we will get, I'm going to give you the simple example. What is the output we are getting here? In the first case, the output is your 4. Second case, the output is 5. then 6, then 7, then 13. This is the output we are getting, the simple data we are giving to the machine learning. If you are going to check, this is the value of x, and what is the output for first value? The output is 4. What is the output for second value? The output is 5. What is the output for third value? The output is this one. Now we are going to use one simple model that is called the linear model. So we are going to use from sklearn dot linear, we are going to use one linear model called linear regression, and then simply we are going to fit the model. If you are going to fit the model, and after that if you are giving any number like that, model dot predict, and if I'm going to give any numbers like that, something like that, 6, 7, 8, you can see what value it is predicting the next number equal to 9. You can see it is predicting. If you are going to change the value like 50, 60, and the next number if I'm going to write 70, 50, 51, 51, and the next number we are going to write 52. Now you can see it is predicting the next number equal to 53. How it is predicting? This is just like a linear regression. They are making one regression like that. What is the value of m1 into first number called x1, m2 into second number called x2, m3 into the third number called x3 plus constant. This is called the simple linear regression. What is the standard equation of linear regression? M1 x1 plus M2 x2 plus M3 x3 plus C. If you are going to check, we are giving the 3 input 1, 2, 3. This is your x1, x2, x3. If you are going to find what is the value of this one, you can also find model dot coefficient. It will give you what is the value of M1, M2, M3, and what is the value of intercept. You can also write intercept equal to this one. This is the value of C. So what it is writing, if you are going to check, it is making this type of equation. As a human, what equation we are making? If you are going to check this one, it is making the equation. If you are going to find the next number 0.33 plus 2, it is making this type of equation. As a human, what we are making? Simple, we are adding the plus 1 to the next number. But if you have given this data to the machine learning, the machine is going to find the patterns for you, and this is the right pattern. Even if you are going to check, can we write 0.33 nothing but equal to x1 by 3, this is nothing but equal to x2 by 3, and this is nothing but equal to x3 by 3. It is simply saying you have to take the average of 3 numbers and then you have to add plus 2, you will get the next number. It is saying something like that. So as for example, if I'm going to take what is the average of this number, if you are going to take, you will get the same result, whatever the results we are getting, 50 plus 51 plus 52 divided by 3. Now you can see the same values we are getting. Now if I'm going to change the data, now I'm changing the data, you can see 2, 4, 6. Next data we are changing. Next one we are changing 4, 6, 8. Next one we are changing here 6, 8, 10. Next one we are changing here 20. We have to give some data 20, 24. Next one we are giving the data something called 50, 52, and the next value we are giving as a 54. What is the output for first one we are getting? 8. What is the output of second one we are getting? 10. What is the output of third one? 12. What is the output of next one? 26. What is the output of next one is called 56. Now we have given the data. Now you can see this code remains same. We are not changing the code. The code remains same. We are only changing the data, and it will start working for the new scenario 52. And if you are writing 54, it will predict what is the next number equal to 56. You can see it is predicting for the next number how it is getting. And if you want to check what is the coefficient, the same coefficient it is making, and it is adding plus 4 to the next number. Whatever the number you are giving, as for example, now I am giving the next number 1, 2, and this is a summation of last two number. What is the value will get? 3 plus 2, 5. If I am going to write 2, 3, 5, 2, 3, 5, the next number will get 5 plus 3, 8. 5 plus 3, 8. Next one we are giving 4, 6, whatever the number you want to give, you will get 3, 5, and this is your 8. The next number will get the value equal to 30. Whatever the value you want to give, you can give it 20. The next number your 21. This value become 41, and we are going to add the last two number. This value becomes 62. You can see this is the input we are giving. Now we have changed the input, and this time what is our logic? Simple, the next number is the summation of previous two number. 2 plus 3, 5, 5 plus 3, 8, 3 plus 5. Now we are going to check whether the machine learning is going to identify the patterns for us or not. Now you can see, if we are going to check, it is adding the last two number 52. If you want to check what is the coefficient it is coming, this is the coefficient it is coming. You can see it is, if we are going to check, this value is coming approximately 0, and this two value are coming 1, and this is also coming approximately 0. So try to understand, if you are going to check, this code remains same. I'm not changing this code, I'm only changing the data. And this code will start working for your application. This is the major motivation behind every company that is moving towards the machine learning. Because whatever the codes they are going to write, they will write for only one time. Most of the time they will not. They will write this code for only one time, and the rest of the time they will use the same code. They will only change the data. They will only change this data, and it will start working for the new application. So this is also one motivation behind every company that is moving towards machine learning. Okay, so that's why if you are going to check, I have already mentioned, it will help to enhance the decision making, and the last one, it will also try to reduce the error. Because as we know, the machine have no any sentiment. Whatever the decision they are going to take, they will take their decision based on the patterns. They are not using any type of sentiment. But as a human, whatever the decision we are going to take, our sentiment is also involved there. But if you are talking about the machine learning, machine has no any sentiment, no any emotion. So whatever the decision they will take, that is completely safe. So that's why if you are going to check, it helps to reduce the error in your system. Now, if you're talking about the simple machine learning, I will not take too much time. Simple machine learning, then the machine learning is same like your human learning. Same like if you are going to check, when I am asking you the question 1, 2, 3, 4, what is the next number? You are using your previous knowledge to find the pattern. How to find the pattern for 1, 2, 3, 4 to predict the next number? If you are going to ask the same question to the LKG standard student, maybe he or she will not give you the answer. What is the next number if the number is 2, 3, 4, 6? You cannot find, because he or she has not gone through those type of training. He or she has only idea about how to write the number 2, how to write the number 3, how to write A, how to write B, how to identify different animals, different vehicles, something like that. Okay, so what we have mentioned like that. So the same like your machine learning, if you are talking about, I have given one simple example. If someone will ask you, what is this object? You have no any confusion. Directly you can say this object is a car. How we are saying? Because we have gone through this type of object. We have already idea what types of object we can call it as a car, what types of object we can call it as a truck, what types of object we can call it as a bus, what types of object we can call it as a plane. We have already idea. But if you are going to ask the same question to the person who is staying in forest, who have never seen these types of object, then in this case, what will happen? This person will not give you the idea whether this object is car or bike. This person will try to correlate with this one with all the objects, whatever the object exists inside the forest. And based on that, it will give you some answer, but it will not give you the answer as a car. Now, because it is a human, and if someone will ask you to give the training to this person, our procedure is very simple. What we have to do like that? We came with some type of images, and then we have to explain this concept to this person. We have to explain like that. If you are looking at an object with this much size, with four wheels, we can call it as a car. And if you are looking at an object with 2 wheels, we can call it as a bike. Once this training got over, this person got the knowledge about all the animals plus the different types of objects. And if you are going to ask any question, directly it will give you the idea. So the same procedure we are also going to follow in our university system. The similar procedure we are going to follow. What we are going to do? If the student have no any idea about any subject, we are going to conduct some classes. We are going to deliver the content. And after that, once the content is delivered, then we are going to conduct some exam. And based on that, we are going to find what is the performance of the student. So if you're talking about the normal machine learning, the machine will only follow your instruction. Whatever the instruction you are giving, I'm not talking about the machine learning. I'm talking about the normal machine. it will blindly follow your instruction. Whatever the instruction you will give, it will completely follow your instruction. So as for example, as for example, car, if you are going to click the accelerator button, the car will move forward. It will not give you any type of hint like that whether the road is not there. It will not give you any type of hint like that whether the wall is there, and you cannot click accelerator button, because if you are going to click accelerator button, the car will move forward and it will directly hit the wall, because this is a machine. So whatever the instruction you are giving to the machine is going to assume like that you are giving the right instruction. This is not a machine learning. But if you are talking about the machine learning, how we can make the machine learning? The same procedure we are going to follow, whatever the procedure we have followed in our human learning. If you are going to check in the code, we are giving some data to the machine. This is the data, and for this data, this is the output. For this data, this is the output. For this data, this is the output. Now the machine is going to find the pattern. It is going to find the logic, how we can find the relationship between these three variables to last variable. And based on that, it will give you the answer. So the same procedure we are going to follow. Whatever the data we are using for the training, we cannot use the same data for testing. Once the machine is going to be trained, we have to also check whether the machine had the ability to predict those values or not. So if you are going to check, once the machine is trained, now we are going to find, we have to test this machine on the testing data. That is completely different. And once you have confirmed that our machine is working fine for most of the scenario, then this machine become intelligent. Now this machine will treat like as a human. How the humans are taking the decision, the same way the machine will also take the decision. So this is the normal, simple way we have explained you what is the machine learning. So now I'm not going for the supervised. These are the different application. I'm not going through the application part because this is not that much important. So directly we will jump to the NLP part. Okay, because this session we are planning to go for NLP. Okay. But before that, first we will come for yeah. So now before going to the NLP, first we'll go for the what is the journey of machine learning, when the machine learning got it started, and what we are doing for the automation before machine learning. So if you are talking about the first type of automation, it's called the rule-based learning. As a human, we are designing the rules for machine. We are designing the rules. If this is the rule, then you have to follow this instruction. If this is the condition, you have to follow this instruction. If this is the condition, you have to follow this type of suggestion, something like that. So these rules are written by the human to produce the results. Okay, but when the data size is going to be increased, at that time the rules are not sufficient. Whatever the humans are writing, that are writing the general rules, that are not writing the exceptional rules. But now the concept of machine learning came. In 1990, now the concept of machine learning came, and in this case, we are not giving the rules for the machine. The machine is going to identify the rules for us. We are only giving the simple the data. This is the data, and the machine is going to identify the patterns inside the data. That is called the machine learning. Okay. After that, when the trends got changed, everyone companies start applying the machine learning because they are getting some benefit. They are getting some hidden pattern that help to take some type of critical decision. So now the most of the companies start moving toward the machine learning, and they are planning to apply the machine learning for any type of data. Initially, they are planning to apply the machine learning for numeric type of data, but now the trends change. They are getting the different types of data. They are also getting some data in the image format. They are also getting some data in the video format. They are also taking some data in the audio format. They are also taking some data in text format, some number format. They are getting the different varieties of data. Then in this case, the machine learning is not sufficient. So that's why now the new concept came called deep learning. And the deep learning architecture is same like your human brain. How your human brains are working, the same way deep learning architectures are designed. Here also the concept of neurons are there, and based on that, how the humans are taking the decision, the same way the deep learning is also going to taking the decision. After that, the trends change. Now some companies start working for the pre-trained model. So if you have no any data, still you can use the machine learning model. And then they came with the concept called generative AI. Generative AI means the concept is very simple. What they have done like that, they have taken all the data, whatever the data present in the Google. If you are talking about the coding part, they have taken all the codes from GitHub repository. They have taken all the comments from the Stack Overflow, Quora, everywhere, whatever the codes present inside the internet, they have taken all the codes, all the data, all the text format, all the Wikipedia content, and based on that, they have designed one type of model. And this model is expert in all the area. If you are going to ask the question related to the computer science, they will give you the answer. If you are going to ask the question related to the mechanical engineering, they will give you the answer. If you are going to ask the question related to anything, they will give you the answer. But the question is how we can use for our application. As for example, if you are going to ask the generative AI, write one application, leave application. It will write the leave application for you, but it will write based on their content, based on their experience. Maybe it will write the leave application that will pointing to the principal, because most of the time the students are asking to write the leave application. Now we are saying no, 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 in my case we have to report to the director of the institute. They will modify the leave application and they will write the director to the institute. After that, if you are giving no, 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 I'm only taking the leave due to medical region, they will write the medical region. Okay. And once you have confirmed that yes, now this application is fit for me, now in the future if you are going to ask the LLM to write the application for you, they will simply write the application, leave application to the director. They will also write the 4 days region. They will also write the 4 days. If you are asking like that, I need 4 day leave, they will write those type of medical region where you need 4 days leave. Okay. The same like that, if you are talking about the same, it is, you can also assume like this is similar like as a doctor. Doctor is expert in all the area. If you want to use the doctor for your purpose, you have to communicate with the doctor, you have to explain your problem, and based on that they will suggest you the solution. The same like your generative AI is working. He is expert in all the area, and if you want to use for your application, you have to do some conversation, or you have to give the proper. Generative AI concept is totally based on the large language model. If you are going to check, this is totally based on the large language model, and there are various types of large language models are there. Either you can use GPT-3, GPT-4, or you can also use the Gemini model, or you can also use the DeepSeek. These are the different types of large language models out there. After that, now the trends change. Now we are also using the multi-modal generative AI. If you are going through the multi-modal generative AI, now you can also generate the video. Now you can also generate the different images. If you are going to check nowadays, the trends are totally changed in the social media. If you are going to check, like there are some monkey who is speaking, who is giving the some explanation to some concept. You can also assume like that. You can also make some video. You can write simple prompt and it will make the video for you. Whatever the content you are giving, simply it will generate those type of content that will come under the multimodal generative AI. After that, nowadays we are also using the agentic AI. Agentic AI. In the case of agentic AI, it will also take the decision. If we are talking about the generative AI, it will give you the output. Yes, this is the application for you. But if you are using the agentic AI, it will also directly send the mail to the director. Once you have mentioned like at this time, you have to send the mail, directly it will write the application and directly it will write the mail to you. Same like that. As for example, if you are going for some flight booking, if you are using generative AI, it will compare all the flights and it will give you the best flight for you. Okay. But if you are using the agentic AI, it will compare all the flights and it will directly book the flights for you and directly it will send the tickets to you. That is called the agentic AI. Okay. So now we'll go for this. These are the different concepts. The first one I have already mentioned, that is called the rule based, where as a human we are going to write the rules. Now these rule based are only valid if you are working with some limited type of data. If you are working with a fixed type of pattern, then the rule based is fine. Now after that, we have shifted to the machine learning, where we are not giving the rules based on the data. We have the data, and the machine learning is going to identify the rules for us. That is called the machine learning. and that will normally work for the similar type of data. But if you have the different varieties of data, then you can use the concept called deep learning. And if you have no any data, then you can use the concept called generative AI. Okay, and there are various varieties of the generative AI. So these are the normal journey of the machine learning, how the machine learning has started, and what is the current area of research going in the area of machine learning. Now we are going to take one simple example of natural language processing, because your generative AI totally based on the NLP, totally based on the NLP, because we are doing some conversation and based on that it is giving the answer. I mean, the core concept is totally based on the natural language processing. So there are various application of natural language processing. Either you can use for language translation. You have to translate English to Chinese language, English to Hindi language, English to Telugu language, English to Kannada language, something like that you can generate it. Second one, your sentiment analysis. You can also use for sentiment, whether the sentiments are positive or negative. How many publics are giving the positive sentiment, how many publics are giving the negative sentiment, because you already know the demand or power of the social media nowadays. So when the government is going to launch any type of a scheme, they are also going to check whether the publics are happy with this scheme or not. How they are doing? They are doing the sentiment analysis of the public opinion. Then you can also use for a spam filtering. If you are getting any mail, basically it will decide whether it will go for email or it will go for spam. We are also using, in my area, we are also using for software defect severity level prediction. So when anyone is giving the complaint related to any software, what level of severity is there, whether these are the normal defect, whether these are the critical defect, whether these are the major defect, that we have to inform. So these are the project normally we are working on in the area of NLP. We are working on the software defect severity level prediction, sentiment analysis for software engineers. So if any software engineers are giving the comment whether they are feeling happy or whether they are feeling sad. Fake news detection, fake job posting prediction, Twitter airline sentiment analysis. We have also worked on the COVID-19 data analysis. But these are the major challenging when you are working with the area of natural language processing. The first one is called the word embedding. Okay. The second one is called the high dimensional data, and third one is called the imbalance data. Okay. So word embedding technique means that we will discuss. If you are using the traditional method, either you are using the TF-IDF or if you are using the count vectorizer, you are getting the huge number of features. And even you cannot make any type of such conclusion like that, whether the two words are similar or not. Which two words are more similar? You cannot make these type of conclusion if you are using the TF-IDF or count vectorizer, because it will only give you the values like that 0 1, or it will give you the terms frequency, what is the frequency. So based on that you can only take the decision whether these two words are same or not. But if you are using the word embedding, this is just like one type of dictionary that will give you the number representation of specific words, and these numbers are designed such a way that for two similar words you will get the similar number, same like your latitude and longitude, it is defined. If you are using the TF-IDF, we are using the all unique value as a feature, all unique word as a feature. So we'll get the huge number of features. So here you can also use some approach to handle the high dimensional data. And after that, if you are going to check for any sentiment analysis, most of the comments are positive comments. There are few comments are the negative comments. So that will also see how to handle the imbalance data. Okay. So these are some basic part that we have discussed. Now we are going for the main part. These are only the theoretical part I have discussed. Now we are going for the main part called coding part. So if you are going to check few code I have written, if you are working for text mining, always you have to use this code, okay? Because there are some package we have installed, we are planning to use. So we have used one package called Gensim. Then we have also using one package called Google Generative AI, because this session is for generative AI. So we are going to use one Google Generative AI. We are also planning to use the LangChain model. If you are planning to develop some simple application, then directly you can use the concept called LangChain. We are also using the OpenAI. If you are going to check, we are also using the OpenAI platform. OpenAI means the same like your ChatGPT we are using. After that, if you are going to check, we have the paid version of OpenAI, and we are using the free version of Google API key, and that you have to put inside this key folder. You can see inside the key folder, I have put it all the values. You can see like that. These are the key for my Gen AI. Okay, so simple. You can put it here. I'm going to share the code with you. This is the API key for OpenAI and API key 1 for Google API key. So I have already mentioned we are planning to compare which one is the best model. Either you will go with Gemini or you can go with the ChatGPT, or also called the Open API. The next one, I have written the simple code for cleaning the text. If your data contains some bad symbols, if your data contains some hyperlink or URL, it will simply remove those type of things. So that's why we have written here. This is called the clean text pipeline, or you can also call it as a clean text. There is no any problem. So directly we are writing this is called the clean text. Okay. Now I have also downloaded here one called word embedding. What is the use of word embedding? You can also check. As for example, NLP of NIT, if you want to check, this is the number you can represent for NIT. This is the number. How we can represent the NIT? This is the number. Whatever you are going to write, if you are going to write for VNR, VJIET, we have to check like that whether the embedding, no, there is no any embedding for the VNR, VJIET. If you are going to check for the CSE, you have to check it here whether the embedding say yes, CS for CSE embedding is there. If you want to check for EC, you can simply check it for, it will give you the embedding for EC. And these embeddings are designed such a way that for a similar words, you will get the similar type of value. For a similar words, you will get the similar types of value. If you are writing IT, you will also get some type of embeddings. You will also get some type of embedding. Clear? Now after that, this one we have discussed. So now first I'm going to take one data here. So this one is not regard, this one is only for your understanding purpose. So first I'm going to take one data here that is called the train underscore claim. So I'm going to read the data. Our approach is simple. We are going to use one package called pandas, import pandas edge pd, import numpy edge np. Even if you have no any idea about the coding, you can also generate the code. You can see, you can also generate the code. If I'm going to write something like that, read train clean data, read train clean data. If I'm going to write, automatically it will generate the code for reading train clean data. You can see automatically it will generate the code for reading train data. You can see automatically it is generating the code for reading train data. You can see. So even if you have no any idea about the coding, you can also generate the code by using the concept called generative AI. When you are going to click here, you can also generate code. Whatever the code you want to generate. As for example, I want to I need code for sum of two numbers. I need the code for sum of two numbers. Simple, I am writing. I need the code for sum of two numbers. You can see it start working and it is giving the code for sum of two numbers. You can see it is giving the code for sum of two numbers. This is the code. Now, if it is not written the right code, you can also write a I want to take input from user. I want to take the input from the user. It will modify your code. Whatever the suggestion they have given you, it will modify the suggestion and it will write the code for taking the input from the user. You can see it is taking the input from the user. So always it will modify, means you can easily use this one to write this value. Okay. So if you are going to check, this is our DF value is there. This is our data. data that is present in the variable called df. And if you want to find what is the total sentiments we have, we can also write sentiment dot value count. It will give you the idea how many sentiment belongs to the each category. So we are writing via a value count. So it will give you the idea how many positive sentiments are there. 8,264 are the positive sentiment, and how many negative sentiments are there. 7,181 are the negative sentiment. So first we will start with the traditional method. Then we'll go for the if the deep learning method, then we'll go for the generative AI, or maybe first we'll go for the traditional, then we'll go for the generative AI. If the time left, again we'll come for the deep learning approach. So what we have done here, if you are going to check, this is the sentiment we are getting. First, we are going to apply the clean text on selected text, because if you are going to check, there are two features here. One is your selected text, and second one is your sentiment. So we are writing df dot selected text equal to df dot selected text dot apply clean text. So we are simply applying the clean text. It will check if there are any words are like that. It will simply remove those values. And you can see this is the data we are getting after clean text. So if you are going to check here, we are getting so sad sons, SONS. Here we are getting the value equal to son. So it will remove all the numbers. If you are going to check, I have written this code, and when you are working with the text mining blindly, you have to use this function called clean text. It will do all the thing. If you are going to check, it is going to remove the URL. It is going to replace some bad symbols. If there is any bad symbols are there, it will replace the bad symbols. It will also replace any words are there. If any stop words are there, it will also do the lemmatization for you. It will also find the root meaning of a specific words. So after cleaning text, our data is clean. If you are going to check, our data is clean here. Okay. Now we will go for the next analysis. Our data is clean. There is no any problem with this data. So first we have to convert, because we already know the machine learning is just like a mathematical model. So mathematical model means it will only work for numeric data. It will not work for text data, because this is a mathematical model. So it will only work for the numeric data. It will not work for the text data. So first our objective is to convert the numerical feature into text. First our objective is to convert the text data to numeric data, and for that we are using one traditional method that is called the TF-IDF. But before that, first I'm going to convert this sentiment positive and negative to 0 and 1. So for that we are using one label input. So we are writing from sklearn dot preprocessing input label encoder. We are going to use the label encoder. Simply we are writing LE equal to label encoder. We are going to use here label encoder. Then we are writing here data of df of sentiment equal to LE dot fit transform. So simple, we are writing df of sentiment equal to LE dot fit transform, and if you are going to check, after that the sentiment is directly changing from 0 and 1. Initially the sentiments are coming positive and negative, so now we have changed with the 0 and 1s. If you want to check which one become 0 and which one become 1, you can also write here data of classes. It will give you which one become 0 and which one become your 1. So 0 means negative and 1 means positive comments. Okay. Now we'll go for the selected text. So for that purpose, we are using one concept called TF-IDF. So simple, we have write from sklearn dot feature, because that will come under the feature extraction technique. So we are writing sklearn dot feature extraction dot text. This is the feature extraction for the text mining input. We are using the TF-IDF vectorizer. So we have to use this TF-IDF vectorizer. You can also use the one hot input. So TF-IDF vectorizer we are using. And if you are going to check, automatically all the codes are coming here. If you are going to check what we are writing, x equal to TF equal to this one, x equal to this one. And after that, if you are going to find, this is the value of x, we are getting np dot shape of X. We have to check what is the shape of X. It is coming 5809. The total number of features it is coming 5809. How many features are coming? The total it is coming 5089 feature. And if you want to check what are the features, those features name, you can also write here get underscore feature name out. It will give you these are the features name that is present in your data. These are the features name that is present in your data. And if you are going to check, it is going to consider only one feature. Here you can also write how many maximum feature you want to take. You can also write, it will give you the top feature, maximum feature. If I'm going to write 500, it will give you the top 5 feature. And you can also write the n gram range equal to 1, 2. It will also consider the bag of word with combination of single and double words also as a feature. So if you are going to write, I'm writing this one. You can see these are the top 500 features are there. And if you are going to check, some case we are also getting the double value. You can see there are some case we are also getting the 2 words as a feature. Because why we are getting? Because we are writing here in grams equal to 1 to 2. Okay. And here if you are going to check what is the shape we are getting the 500. The shape equal to we are getting here 500. Okay. And why we are getting 500? If you are going to check it here, this value we have written here the value equal to 500. Okay, if you are not writing the value equal to 500, it will give you the huge number of feature. You can see how many features it is giving. If you are going to check it here, if you are not writing, it is giving the total 23,000 features are there. When we are taking the n gram equal to 2, n gram equal to 2, it will give you the total equal to 23,126 feature. Can we say all features are important, or can we say some limited number of features are important? That you can also check by using some test called hypothesis testing. So here you can also write same like that. We are writing the label equal to df of sentiment dot values dot value. This is your labels. You can see this is your label value. This is your label value. Okay, this is your label value, and x you already predicted. This is the value of your x here. If you want to check what is your first feature, you can also write comma 0. It will give you the idea about the first features. It will give you the idea about your first feature. What is your first feature? It will give you. So what we are planning to do, why not we have to check? We are going to find what are the positive sentiment. What are the positive sentiment? NP dot where we are getting the label double equal to 1, and what are the negative sentiment equal to NP dot where we are writing the label double equal to 0. Simple, we are finding what are the positive sentence, which sentence are the positive sentence and which sentence are the negative sentence, and we are planning to check if we are using all feature. Out of each feature, how many features are coming as an important feature and which features are those important feature. Then here we are using the concept called rank sum test. So from SkyPy dot statistics input rank sum test. Rank sum test, and then we are going for all the features. So we are writing simply p value equal to np dot zeros, and for every feature we are checking, so we are writing np dot shape of x of 1. Now we are going for all the features. We write for I in range of 0 to np dot shape of x of 1. This is the total number of feature, and for every feature we are calculating what is the p value we are getting here. P value of I is nothing but equal to rank sum. You can see this is the p value we are getting here. The simple we have written. What is your positive sentence? What is your negative sentence? Simple, we are changing to the array and we are calculating what is the p values we are getting here. You can see automatically it will start working for all the application, and we will find how many are the features are important feature where the p value is coming less than equal to 0.05. These are the only important feature, and if you want to find what is the length of in1 of 0, it will give you the total number of important feature, and which features are important, it will also give you the index of those features. So when we are taking the 23,000 feature, you can see 23 out of 23,000, how many features are really important for the sentiment analysis, that we are going to find it from here by using the rank sum test. So now it's working. It will take a little bit time and it will give you the output. So it's still working. Once it will complete it, we will see what is the output we are getting here. So still it is working. Once it will take a little bit time, not too much. It will take 1 more minute time, and after that it will give you the output. So once it will done, then we have to decide whether we have to write the maximum feature or whether we have to not write the maximum features. So now you can see still it is working. Once it will done, you will get the output. So yeah, see, if you are going to check how many features are important, only 26 out of 23,000 feature, only 26 feature have the ability to distinguish between positive and negative sentence. And if you want to find what are those words, what are those features, then you can also write these are the only feature, these are the feature, these are the features. If you are going to write of in1 of 0, these are the only 20 features are the important feature. Okay, now the same thing, if I'm going to write here maximum feature equal to 500, can we get the same result? So now we are writing maximum features equal to 300. We are going to write here. We are not going to write too much. Now you can see these are the features out we are getting. If you want to find the np.shape equal to this one, this is your label, positive and negative. You can see this is the values we are getting here. in1, these are the 26. Again, you can see when you are taking the top 300 feature, again we are taking the same 26, and even if we are going to check, the features are coming almost same. Features are coming almost same. So when you are working with the TF idea, there is no need to consider all feature. You have to always write what is the maximum number of features you are going to consider. Clear? Once it is done, now we are going for simple model development, and then we'll see what is the output or what is the accuracy we are getting based on this model. So we have already calculated. If we are going to check, we can write x1 equal to x2 to x2 array so that it will work. And then we are going to take the training and testing data. So simple, we have tried for training and testing data. We are using the from scalar dot model underscore selection import train and test split. We are using the train and test split, and we are finding what is our TR data, what is our TS data, what is our TR actual, what is your TS actual is nothing but equal to train and test split. If you are going to write here train and test split, what is your x1, what is your level, what is your test size, we have to write test size equal to this one. And if you want to shuffle the data before that, you can also write here shuffle equal to true. So you can see this is the code we have written, and it will give you what is your training data and what is your testing data. So we are finding if you want to normalize the data before that, you can also normalize it. There is no any problem. You can also write sklearn dot preprocessing import standard scalar, and we are also going to normalize the data here. A standard scalar equal to this one. So here what we are going to do, first we are taking this data, we are going to normalize the data sc.fit underscore transfer. So you can see this is your training and testing data we have calculated, and after that we are taking one simple model called decision tree classifier. You can take anything. So as for example, if you want to take logistic regression, you can take logistic regression and it will fit the model. Once your model is fit, you can predict and you can calculate the accuracy score. So from sklearn dot matrix import accuracy score. Okay, and we are going to calculate what is the accuracy score we are getting for our data and this one. So this is your TS actual comma model dot predict. So this is the accuracy score. The total we are getting the accuracy equal to up to we are getting 86.675% of the accuracy by using logistic regression. If you want to use some other technique, the approach is very simple. We have right here sklearn dot tree import decision tree import decision tree import from sklearn decision tree classifier. Now you can see, and the same in place of this one, we have to write simple decision tree classifier, and it will start working for decision tree classifier. What is the accuracy of the so first one I am working with logistic regression. Now this is the decision tree classifier, and we are getting the accuracy equal to 86.30%. So our approach is very simple. If you are going to check what is the approach we have followed till now, if you are going to check carefully, then what we have done here, first we are reading the data. This is our data train underscore clean. Once we are getting the data, we are going to find how many are the positive and negative sentiment. This is the values we are getting. Then we are finding, we are cleaning our text, okay, and after that we are going for the label encoder. So first we are going to convert our positive value to 1 and negative value to 0. Once it is done, then we are using to convert the selected text, whatever the text are there, we are selecting by using the number format, by using the TF-IDF. Once it is done, now we are also going to find what are the important feature. You can see these are the important feature. Even this is the whatever the output we are getting based on the all the feature. You can also try to check based on the important feature. What are the important features are there that is present in IN1 of 0. You can see these are the only 26 are the important feature, and if I'm going to select design the model based on the important feature, you can see how much performance we are getting. 70.41 means the performance is little but reduced because we are using the less number of feature. So this is just like a for motivational purpose I have given you the ransom test value. So what we have done, this is the features we have calculated, and after that we are finding how many are positive sentiments, how many are negative sentiments, and then we are going for the final model development. Then we are going for the final model development. Again, I'm going to try how much accuracy it is giving here. So this is the value. This is your tf dot features. This is your np dot save sentiments value, positive and negative. This is your z values. How many important feature? These are the important feature. What is the name of the features? It is coming. If we are going for that, we are going for the model dot tray, and it is coming 70.44. If you want to use, if you have, remember we are first initially we are using logistic regression, and then we are using here decision tree classifier. Okay, decision tree classifier. If you want to use all the classifier, whatever the classifier present inside the sklearn, you can also use by using the simple command. You can see from sklearn dot utils from sklearn dot utils import all estimator. It will give you all the estimator, whatever the estimators present inside the data. It will give you all the estimator, whatever the estimators are there inside the sklearn. It will give you all the estimators here. So now we'll see if I'm using all the estimator, what are the outputs we are getting here. So that we'll see it here. So if you are using all the estimator, what is the output we are getting, whether we are getting the same output or we are getting the different output. Okay, so here if you want to find all the estimators, I have already written here, this is called all the estimators here, and then we'll see what is the output we are getting here. So till now, if you have any questions, then let me know. Anyone, any question? Till now, if you have any question, then let me know. Okay, so if you have no any question, anyone, any question? Anyone, if you have any question. So if you want to find all the estimators, simple, we are going to write estimator equal to all estimators, whatever the estimators you have. And basically we are working with classification type of estimators. So you can see these are the all the models here. Anyone, any question? If you have any question, let me know. Anyone, any question? Your voice is not coming. If
Sir,
you have
I
any,
have a question.
yes, tell
Sir,
me.
I forget, sir, which tool you are using, sir, actually.
Google Colab. I'm using Google Colab. This is a free of cost tool. I'm going to share the code with you also.
Sir, in sir Google Colab, there is predefined syntax of whenever you are writing,
Hmm.
it is automatically comes. So this is a tool, sir. Is it easier? So that we can
Yeah.
learn.
Yeah, this is an inbuilt Gemini tool. If you are going to check the top one here, you can see this is an inbuilt Gemini tool. It will help you while writing the code. If you are going to check when I am writing the one sentence, automatically the extra sentence are coming.
Okay, sir.
So here we are also using the generative AI concept. You can see this is your generative AI, Gemini.
Okay, sir.
Okay. Yeah.
Yes, sir. Thank you, sir.
Thank you. So if you are using, initially have tried with two simple logistic and decision tree. If you want to use all the estimator, whatever the estimator present inside the SK learn, then you can simply write all the estimator and you can see these are the estimators are there. You can see these are the estimator, all the estimator, whatever the estimators are there, every estimator is here. Okay. If you want to find what are the models for every estimator, you can simply write it and it will give you what are the models for every estimator. So now we are going to find the models equal to this one, and we are going for, if you are going to check the first one your name and second one is your model. So we are writing here for name comma model, what is your model in estimators, for name comma models in, this is the name we are going to write, because if you are going to check, basically it will contain what is the name of the estimator and what is this one. And now we are going to append only model dot append, whatever the models we have, we are going to append it. So if you are going to check, it will append all the models, whatever the models we have, it is going to append all the models here. You can see these are the different models we have. If you want to find how many models we are getting, these are the number of models we are getting. The total 44 different models are there. Total 44. So you can use all the 44. I'm planning to use all 44, and then we have to check in which case we are getting the better result. Which case we are getting the better result. Our approach is same approach, whatever the approach we have followed here. We will use the same training and testing data, and then we are going to find what is the output we are getting here. So our approach is very simple. First, I'm going to make one ACV equal to np.zeros. We are creating one variable where we have to store the accuracy with every model. So we are writing length of the model. We are going for mod in model. We are getting the model. Simply we have to write mod.fit. What is our TR data? What is our TR actual? Okay. And here we are writing the I equal to 0. Now once it is done, now we are writing the ACV of I equal to accuracy score. What is the accuracy score? What is the accuracy score of TS actual dot mod of predict? And we are going to store the accuracy score in the terms of 100. Okay. Once the model is trained, if you want to print, you can also print which model you are working on. So you are also going to print the model here. Okay. So if you are going to check, there are some scenario we are getting the error. If you are going to get the error, you can also write here. This is your try. If you are getting the error, because there are some scenario where you have to give the some extra attributes, extra feature value. We are not giving the extra feature value except exception A, and we are going to simply we are going to pass it. So we are not doing anything, only we are going to calculate for this one. Okay, so if this values we have to write here I equal to I plus this one. So now we are going to check whether it is working or not for any scenario. For all the scenario it is coming the 0 value, so it is coming 0. We have to check slightly, we are doing some mistake, that we have to check it here. So what we have written for name, and this one we are going to use the model. So we have to write here model. This is called the model. Okay, so missing one parameter, again we have to use the same thing, try, because some case we have to give some more argument. We have to give here except exception E, we are going to pass the model. If you want to check how many models we have, these are the number of models we have. total 35 models without any argument you can pass. And if you are going to calculate the slate values, you can see all the models start working. The first one, your header boost classifier, bagging classifier, Bernoulli naive Bayes. These are the different categorical naive Bayes, complement naive Bayes, whatever the 35 classifier, because some classifier needs some extra input and that we are not giving here. Okay, so randomly we are running here, and if we are going to check, once it is done, we will also check which classifier it is giving the best result, which classifier it is giving the best result. So that we will also see. So now it's working, still it is working. Approach is very simple. If you are working with regression, in place of classifier, what we have to write? Regression. It will start working for all the regression. Okay, and how many estimators we are getting? The total 35 models we are getting. We are going for every model. We are also going to check if we are getting any type of error. We are passing those errors. Now you can see it start working. 1 2 3 4 5 6 7 8 and 9 10 11 12. It is working on 12th number. It will take little bit, it will take some time. If you want to check, we are also going to print here. Just you can see, instead of writing here, we are also printing the ACV of I. So just yes, it is taking a little bit more time because we are working with 35 different models. Definitely it will take a little bit more time. So now you can see, if you are going to check the first one, it is giving 67.30, second one 70, because we are using only the selected set of feature. If you are using all feature, it will work for all the data. So now first I'm going for this one, and then we'll work for all the data. So the same code I'm going to copy paste here, and it will start working for all the data here. And instead of taking all the data, we will work for only, because it is taking a little bit more time. So now we are planning to work for maybe first 1000 sample we are planning to work, and same like that we are writing the label equal to the label of first 1000, because it will take time. If you are going to check, if you are working for all the sample, definitely it will take some time. So what we have decided, why not we have to work for some samples. Now I think it's already crashed. Okay, again we will start from here. So it will take a little bit time, not that much time, because we have the limited RAM. That's why, because we are working with very huge data, 15,000 sample. So we have to give some limited data for all the. If you have the RAM, you can use it for all the data. So now just 1 second. So again it will take a little bit time, not too much, because our system is crashed due to limited resource. Now once it is done, we are going to install the generative AI, LangChain community, S1. Okay, we are going to take the Gen AI. That will little bit, it will take the time. So simply you have to click, it will work for all the sample. Now we are going to take this data. Once we have taken, we are going to count it. Level encoder, this one, your TF-IDF, how many features are there? It is giving those features value. This is the values we are getting here. Level equal to 0, level equal to 1. If we are going to find how many features are coming, important one, that we have to write it here. Now we are taking the standard scalar. Here you can fit it. We are taking the simple decision tree. It will calculate the accuracy value. Now we are going for all the estimators. Okay, we are taking all the estimator. Now we are taking the model. This is the total number of models we are getting here. And now we are planning to work for these number of sample. So instead of working for all the sample, why not we have to work for only 1000 sample. So now it's still working. We have to check how much it is completed, because it will take a little bit time while running the. So LangChain community is almost completed. And if you want to access this code, I'm also going to share with you. So this code is still working. I'm also going to share with you. You can check this code with this link. Okay, so if you want to check, you can check this code with this link. This is the code, you can see. Okay, If you are talking about the input we are giving here, you can see this is the input we are giving here, and this is the input. Here you can see train clean, and this is the input. We have to put our input in this folder. You can simply select it here, which input you are working on. Simply you have to select and you can put inside this folder. The approach is very simple, and this is the data. Even if you are writing a simple train clean, it will also work. So I have shared the code with you also in the chat. If you are going to, you can go through the code. Okay, this code is working. It will take 2 or 3 more minutes. Only this step it will take a little bit time. Once this step is completed, then after that it will not take much time. So only this step it will take a little bit time. Okay. But if you are going to check here, we are doing the step by step. Even if you are going to check, we are using the different steps here. You can see first we are reading the data. After that, what we are doing like that, we are changing this value. If you are going to check, we are applying the clean text here. Okay. Once after applying the clean text, we are also changing the sentiment value 0 and 1. After sentiment value, we are applying the TF-IDF on the selected text, that we are getting the number format. After getting the number format, we are also selecting the top feature, top 26 or whatever the feature you are selecting. Even if you are not selecting, that is also fine. Okay. Then after that, what we are getting here, we are getting what are the features we are getting. Then we are finding the training and testing data, and then we are going for the model development. Okay, in this model, whatever the models we have trained, in this model, it will always take the input as a, if you're talking about the input, it always take the input as a TF-IDF value. You have to always give the input in the terms of number. But if you want to give the input in the terms of text, you can also make some pipeline. That we will discuss how we can make the pipeline. That is also very important concept, how we can make the pipelines. So now it is working. Because only this step it will take time. Once it will completed, after that it will not take too much time. So only this step, because this one we are going to download the Globe Twitter 200. It has the bigger size, so definitely it will take a little bit time. But before that, we are planning to use here called pipelines. Why not? We have to design one pipelines, and a single click it will work for all the models. So for that one, we can simply use from sklearn sklearn.pipelines, pipeline input. This is very important concept. You can use anywhere. It is not like that we can only use here. Make pipelines. And now we are going to make one simple pipelines here. If you are going to check, we are planning to make one simple pipelines. Whatever the procedure we have followed initially, we are going to follow the same procedure here. Okay. So here we are taking one function transformer, because if we are going to check in the first case, we are going to transfer this function. So sklearn dot preprocessing input function transfer. FUN sklearn dot preprocessing input function transformer function transformer. Okay. After that, we are going to make one pipeline. MK equal to, we are going to make one pipeline. Even if you are going to check, it is giving the whole pipeline. So we are going to make one pipelines here. And you can see how the pipelines we are making here. So this is the pipeline we are making here. The first one we are going, you have to write the step by step. What is your first step? What is your second step? You have to simply write it here. But before that, we have to also transfer this one into series format. So whatever the data we have, simply we are going to transfer into the series format for plain text. So now you can see the first one we are going to write the function transfer. We are going to apply the function transfer called apply chain to the series. apply chain to the screen. And even if you are going to check here, all the steps are coming here. Okay, and we are not going to do any type of validation, so we have to write here validation equal to false. Then we are taking a maximum 300 feature, n-gram equal to this one. Then after that we are going for a standard scalar. But even you can, this feature, it is coming in the sparse matrix, and if you want to convert a sparse to this one, we have to use another approach called this one. You can see. So here, if you are going to check in a single step, whatever the code we have written till now, it is already present in a single step. First, we are going to use the function transfer, where we are going to apply the clean text here. Once it is a clean text, then it will come to the TF-IDF vectorizer. It will find the vector form, maximum feature, it will make 300. After that, whatever the vector you are getting here, it will make the array format. If you are going to check here, we are also making the array format here. You can see X to array, the same thing we are also making the array format here. Okay, once the array format, we are using the standard scalar to normalize the data, to bring all the data in one scale. And even if you are going to check, now it's already completed, now it's start working. You can see the standard scalar we are using, that is the next step we are using here. That is called the standard scalar. So once it is done, now we are going to work for top 1000 feature, only for the 1000 sample, and I think it will start working. So again, I'm going to execute. These are the features we are getting here. This is the np.save. This is the positive and negative sentiments. Okay, so now we are going for here. So we are planning to work for only 300 samples, so that it will not take too much time. We are already running behind the time. Now you can see train and test split, we have already decided. Now you can see it start working for all the models, whatever the models we have. And for all the model, you can see this is the ACP value we are getting for all the model. You can see which model it is giving the better result. You can also find it. You can also find it for first 300 sample, np dot max of ACC. What is the maximum value we are getting here? This is the maximum 90% accuracy we are getting. And which case we are getting, you can also find np dot arg max of ACB. This is the model of A. This is the model have the maximum accuracy. Which model we are using? Random forest classifier. Now you can see what we are doing here. We are making one simple pipeline. You can see this is just like one type of pipeline. Pipeline means first we are going to apply the clean text procedure. Once the data is clean text, if you are going to check, first I am going to show you the procedure. Whatever the code we have written till now, how it is working. First we are taking data. Clear? Once we are getting the data, we are finding this one is not required. We can only, that is used to check. But if you are going to check, first I am going to apply the clean text. Once after applying the clean text, we are applying the TF-IDF. After applying the TF-IDF, even if we will also write later part. After applying the TF-IDF, what we are applying after standard scalar. After applying the standard scalar, we are applying the any type of model. Now you can see the same thing I have written here in the terms of pipeline. What we have written like that, if you are going to check it here, we are making one pipeline. The first one is called this one. You can see it is clearly given which type of. Next one we are applying the TF-IDF. After that we are converting to the matrix format. Next one it will go for the standard scalar, and next one it will go for logistic regression. Now after that, simply you have to read the data. Data equal to pd dot read underscore csv pd dot read underscore csv. Our data name is your train underscore clean dot csv. The same data I'm reading here. Our data is read. We are finding what is our training data, what is our testing data, TS data, what is our training actual, what is our testing actual, equal to train and test split. We are going to take train and test split of data of selected text, selected sentiment. You can see we are not doing anything. Simply we are finding what is our training and testing data, and simply you can write mk.fit tr data comma tr actual. Now our model will fit, and once the model is fit, this is the model is fit, only you have to predict. If you want to predict, you can simply write it here, whatever the value you want to predict. As for example, we are writing you are looking smart. You are looking smart, automatically it will predict the values. Even you can see if you are getting any error, simply you have to write like that, fix this error, automatically it will fix the error. If you are getting in some case, if you are getting some type of error, automatically you have to write fix this error, automatically it will fix the error for you. You can see automatically it is going to fix the error for me. So define clean text, again I'm going to check, this is the models we have. Now we are going to find training and testing. Now our model is fit. Once our model is fit, now you can see this is the output we are getting. You are looking smart, you are looking smart. What is the output we are getting? Positive. This is a positive sentiment. This is the positive sentiment. How it is working, if you are going to check, simple, whatever the procedure we have followed till now, simple, we have made one pipeline. What is the pipeline? The first one we are going to apply this one, the second one we are going to apply the TF-IDF, third one we are going to apply the function transfer, fourth one we are going to apply the standard scalar, fifth one we are going to apply the logistic. Even if you want to apply some feature selection, you can also write from sklearn dot feature selection, feature selection, feature feature selection. We are going to take the select k best, sklearn, selecting the k best. So that is present under the feature underscore selection. You can see, you can simply write from sklearn feature selection, select k based, and we are writing the mutual info classification. You can see after that, if you want to apply feature selection after TF-IDF, you can want to apply feature selection, you can write simple like that. You can write simple like that. There is no any problem with this one. After selecting this values, we are taking the this one. You can see how many top features we are going to select. We are selecting the 50 top feature. You can write it here, simple one. Now you can see this is your pipeline. You can see this is the pipeline, and it will also use to select the top 50 feature. So what we are doing, first we are applying the clean text, then we are going for the TF-IDF appraiser. After that, we are transforming this sparse matrix to normal matrix. Then we are selecting the select k best. Then we are going for the standard scalar. Once the standard scalar, we are going for the logistic regression. And you can see once the data is read, once we are going for the model.fit, automatically it will find what are the top 50 models are there. And you can see this is the output. You can see you are looking smart. It will predict it. It will predict those. Okay. It will predict those values. So you can see automatically it is working. It is working for all the data, and once it will done, it will give you the output. What is the output you are getting? That's done. And this one, maybe it is because we are taking only 50 feature, so it will give you, maybe it will not give you that much good result. You are good. Now I am going to check you are good. That is a positive sentence. You can see. So in this case, if you want to deploy the model, only you have to save the mk.pkl file. Only you have to save this mk.pkl file. You have to load the file, and automatically it will start working for the sentiment analysis. Automatically it will start working for the sentiment analysis. See, in future, if you want to deploy the model, you can simply write like that, store mk bit.pkl file. Now assume that I have no any idea about the coding. I'm simply writing like that, store mk bit.pkl file. Automatically it will give you the command how to store your file with mkl file. Now you can see the sentiment pipeline.pkl, and we are going to dump this file. You can see again, if you are getting the any error, you can also write like that. You have can also write right here, fix the above error. This is also the generative AI. Whatever I'm writing, this is also called generative AI. So even if you have the idea about the proper concept, you can easily write the code. There is no any problem with that. You can easily write the code for you. Okay, so you can see simply it has modified little bit, and it will start. Now it is start writing. It is giving that this is your pipeline. You can see this is your pipeline. What are the pipeline? The same apply chain, maximum feature equal to this one. This is the pipeline. We are taking mk.fit. We are fitting the model. If you are going for predict, we are going to dump the file. Now you can see your file is saved with this one. You can see. So this is the benefit of using the pipeline. If you are not using the pipeline, what will happen like that? You have to save the different model. You have to save this TF-IDF. First you have to save this where we are written TF-IDF. First you have to save this TF value. Next you have to save with save this standard scalar. Next you have to save this clean text. You have to save every value. But if you are using the pipeline, only one file you have to save, and in the future only you have to load this file, and automatically it will start working for your application. Automatically it will start working for your application. So till now, if you have any question, then let me know. If you have any question, then let me know. Any question. Even you can also find what is the accuracy value for this model. Once the model is trained, you can also find the accuracy score. What is the accuracy score for TS actual model dot predict of this one? You can see the accuracy score is 86.92%. You can see. So automatically it is giving, and the simple pipelines we have made. This is the pipelines we have made. This is the pipelines we have made. Okay. So if you have question, any question till now, let me know. Anyone. Because if you are going to check, I have written very simple code. First I'm using the traditional method. This is your traditional method for the sentiment analysis by using TF-IDF. Next we will discuss regarding the embedding, and after that we'll go for the generative AI concept. So till now, if you have any question, you can let me know.
Sir, one question, sir.
Yes.
You are saving the pickle file.
Yes.
Can we save it in some other format like H5 and then?
No. This is the Python model. So model
Okay,
normally is stored in .pkl file. This is a
that
Python
is
whole model.
that is one of the ways, sir.
Yes.
Uh, Even in H5, we can save the model, sir.
H5.
Yeah.
H5. Okay.
Dot
I will check. But
H5
normally we are saving the file in
pickle.
.pkl format. Yeah.
Yeah, sir. I got it, sir. Okay.
Yeah. That we'll see. If it is possible, you can also write it and you can save it. So there is only one command how we can save it.
Yeah, that save command, we can save
Yeah.
our model, sir. No
Yes.
problem, sir. Okay, sir. That's fine.
Okay. Thank you. Anyone? Any other question? Anyone? Any other question? If you have any question, let me know. If you have any question, let me know. Anyone? Any question? Okay. So if you have no any question, now we will take 5 minutes break, and after that again we will start for the next session. So now we will take 5 minutes break, and after that we will start.
Okay, sir.
Yeah. Okay. Thank you. Okay, so can we start?
Yes, sir.
Okay, fine. Okay, so till now we have discussed regarding the TF idea, but there is one problem with the TF idea. So just I'm going to give you the idea how it is working, the TF idea. So for example, if you have the three sentence one we are writing VNR VJ IET. There is one college VNR VJ IET. The second sentence we are writing something college IIT. We are writing VNR VJ IIT. The second one we are writing here IIT. The third sentence I am going to write here, the third sentence I am writing, the sentence 3 equal to, we are writing something called train. The fourth sentence I am writing here, the fourth one sentence is 4 I am writing here called track. If you are going to check, then VNR, VJIT and IIT are the similar words, are more closer words as compared to VNR, VJIT with train, as compared to VNR, VJIT with track. This is your track. Okay. But if you are using the TF-IDF, how the TF-IDF will work is it will simply make the unique words. What are the unique words we are getting? One your VNR, VJIT, the second one your IIT, third one is your train, and fourth one your track. These are the features become, and after that it will simply write the value. So how many times for sentence number 1, how many times VNR is coming? 1 time. This is your 0, this is your 0, this is your 0. Then it will go for the sentence 2. How many times VNR is coming? 1. IIT is coming 1 time. Next value it will come 0 time. Means here you can only make the conclusion like that, whether the words are same or not. You cannot make any conclusion like that, which two words are more similar. That is the problem with TF-IDF. And the second problem is you are getting the huge number of features. So that's why we are planning to use the concept called embedding. And how we can check if you want to check whether IIT in NLP or not. First you have to check whether it is there in dictionary or not. It is there. Simply we have to write NLP of IIT. It will give you how to represent IIT, how to write the number representation of IIT. This is just like one vector representation of IIT. This is just like a vector representation of IIT. Same like that. And these vectors are designed such a way that for similar word, you will get the similar representation. So now simple, our objective is simple. We are going to take the same data and this time we will go for the embedding wise. Okay. And what is the size if you want to find what is the length of single embedding, that your NLP of IIT, the length equal to 200. Okay. The same like your latitude and longitude. If you want to represent any location, you have to represent by using the two number that is called latitude and longitude. Okay. So here we are going to find, we are writing here embeddings equal to whatever the size of embedding. Why not we have to define one function? So we are defining embedding value of any data, whatever the data you are passing. The first one we are finding the dA equal to data dot value. Okay, whatever the values we have. The same like that. What I'm writing, if you are writing here data of selected text dot values, it will give you what is the values present in the first feature. What is the value? This is the value. Basically, it will give you the same values we have calculated here. Now we are going to write how many values we have. So embedding equal to length of, simple, we are writing np dot zeros. And what is the length of this dA, comma 200. Why we are writing 200? Because each sentence we are going to represent by using this 200. So length of dA, comma 100. So simple we have written. So what is the values? The length of the dA. If you can also write, you can also write in the terms of shape. If you want to write, you can also write in the terms of shape. If you have the doubt, you can also write np dot shape of dA of 0. This is the number of. Once it is done, now we are going for every value. So we are writing I equal to 0 and we are going for every review, whatever the comments are given. So for RV in DA, okay, DA ke jagah par in place of DA, you can also write review. Anything, just like a variable, okay. for RV and DF, this is just like every sentence. It will select every sentence of DF. Okay, every sentence that will contain the different types of words. So we are also writing, we are taking the values here, and we are writing for every word. So for R in RV dot split. If you are writing here a split, basically it will find what are the words present in this R. Now we are going to check whether R is present in NLP or not. You can see automatically it is coming whether R is present in NLP or not. If it is present, it is going to append those value. If the word is not present in the dictionary, we cannot find this value. And after that, we are taking the average value. Here you can take anything. Either you can take the maximum of embedding, minimum of embedding. I am taking the average of embedding. Once it is done, if you want to check whether it is working or not, simply we have to write embedding is equal to what is the name of the function we have written, EMB, and we have to write here data of selected text. Basically, we are going to apply on the selected text, and you can see we are getting some values here. This is your embedding value. You can see this is called the embedding value for your. Now we are going to use the same embedding value, and then we will check what are the performance we are getting, and we are using the same code, whatever the code we have used previously. So we are planning to use the same code. This code I am planning to use the same we are planning to use here also. So first I am going for the total estimator. These are the estimators we are getting. What are the models we are getting? And the same thing I am going to copy paste here, and we will work for the top 300 features. Top 300 values. So we are writing the same thing. What we have to write here, x1 equal to, this is the value called embeddings. We are taking the embedding. There is no need to take this value. We are not going to take x1 equal to this one, and the label equal to first 300 we are going to take as a label. Then after that we are doing the same, the model dot split, and we are splitting the data here. So if you are going to check, we got the training and testing data for all the sample. Once we got the training and testing data, after that we are going to apply the same approach. Whatever the approach we have applied here, the same approach we are going to apply for the 300 comment, and then we are going to check what is the accuracy we are getting. But if we are going to check, normally it is giving the better accuracy than previous one. Here we are getting the 90%, some case we are getting 88.38%, some case we are getting 68%, something like that we are getting only for 300. Once it is done, you can also make the pipeline here. Whatever the procedure we have followed, we can also make the pipeline here. The same thing I am going to copy paste here. Instead of applying the TF IDF, why not we have to apply our function? So simple, we have to write the same thing. I'm going to copy paste, and in place of TF IDF, we are going to apply one function. And what is the name of this function? EMP. So we are going to write the name of the function is your EMP. Okay, there is no need to require this one. Simply we have to write this. So now you can see what is the first one. We are going to apply the plain text. Then we are going for the embedding. EMP just like a function, and that is going to calculate the embedding for you. Okay, so again I'm going to take the same thing here. We are reading the data. This is your MK is defined. If you want to check, this is your model. This is your model, and you can see in place of TF idea, we are using EMB function. First, we are reading the data. We are finding what is our training and testing data. So we are writing TR data, comma, and TS data. The same code. Why I am going to write the same code I am going to copy paste. This is the code I am going to copy paste. Training and testing data. Once you got the training and testing data, mk.fit tr data, comma, tr actual. Now you can see we are fitting the model. Again, we are getting some error because some input may contain not a number. Some input may contain not a number. So that's why this problem is coming. Again, if you want to fix, you can fix it from here. Fix the above problem. Automatically, it will fix the above problem. So you can see when we are getting any type of error, and if I'm not able to find how to fix it, simply I'm asking the prompt to fix this error. You can see automatically it is writing some values here. You can see automatically this is modifying the same code it is writing. Automatically it is going to modify here. This is the embedding value. Okay. After that, we are going for the pipelines. This is your pipelines we are getting here. Pipelines, you can see this is the pipelines we are getting. This is your data, this is your data, this is your mk.fit, and you can see there is no any problem which coming here. You can see. So automatically it is fixing those value. Now we have want to predict. If you want to predict any value, simple, you have to write model.predict. Predict, you are looking smart. You are looking smart. You can see it is predicting the value equal to positive. If you want to find what is the accuracy we are getting here, you can also write accuracy score equal to TS actual, comma, model.predict of TS data into 100. This is the accuracy score we are getting here. PREDICT, okay, not model, mk.predict. And you can see the accuracy we are getting 92.10. If we are going for the previous case, what is the accuracy we are getting when we are using the TF-IDF with more feature, we are getting 86.92, and when we are using the concept called embedding, we are getting the accuracy of 92.10. So there are various types of embeddings are there. We are using only one embedding here. You can see we are using only one embeddings here, but there are various types of embeddings are there. So I think it is clear what we have done. We have gone through the traditional method, and then we have gone through the embedding method. And there are various types. You can also use the BERT model, robot model. You can also use the fast text. You can also use the GPT type model. You can also use the different varieties of globe model. If you are going to check, we have used the globe Twitter, globe Wikipedia is there. Even the dimension of the different size also there. But the approach is very simple. Only you have to replace this place, and it will start working for the new embedding. And that we have also checked, if we are using embedding, we are getting the better result as compared to the TF-IDF, as compared to the TF-IDF. So I think till now it is done. Till now, anyone, if you have any question, then let me know. Anyone, any question. If you have any question, then let me know. Anyone.
Sir, kindly set the code, sir. The modified one, sir.
Yeah, code I have already shared with you. Can you please check? I have already shared
It's
with
now
you.
not working, sir. It's not running properly.
Which
So
code?
this one, which one you're working right now?
Okay, so have you tried with my data set? Because maybe you have to change, because some place we are using the selected text. That's why your code is not working for your data.
Actually, my internet connection, it was disconnected in the middle. So
Okay.
it's now not working, sir, properly. So
Okay.
request you to
Yeah,
set the code.
again, I'm going to share with you. Copy link, and you can see this is the code. Okay. Now we will go for generative AI. How we can use the concept called generative AI here. Okay. So the next code, whatever the code we are, the same data we are going to use for generative AI. So here I'm also going to write, we are going for the Gen AI. Okay, this is the generative AI. Before generative AI, if you have checked, I have already got the API key for OpenAI and Gen AI. If you are going to check in the top of the code, I have already written, this is the API key for OpenAI. That is your API key. And for Google API key for Gemini, the name is called API key 1. That you can freely generate. But I am using the paid version for Open API key and free version for Google API key, that is called the Gemini key. Now we'll see how it will work for sentiment analysis, or maybe you can apply for any data. It is not like that only for sentiment analysis. If you are working with machine learning, you can apply this code. Here. You can simply apply this code here. So first I'm going to work for generative AI, and then we'll come to the OpenAI. So first we have to write import Google dot, we are going to use the generative AI concept. So we have to write the generative AI as Gen AI. So we have imported the Gen AI. We have imported the Google dot generative AI. Okay. And here you have to also configure it, whatever the API key you are getting. So we are also writing Jane AI dot configure. You have to configure the file. So we are also going to configure Jane AI dot configure configure, and here we have to write what is our API key. So we are writing it is not suggesting. So API key equal to AP. What is the name? API underscore key. So you can see this one we have already configure the Jane AI. Whatever the API key you have to configure this Jane AI. Once you have configured this Jane AI, if you want to check what are the models that is basically present in the Jane AI, you can also check it. What are the different models that is there in the Jane AI? You can also check it from here. Okay, so Jane AI had the different types of model, and each models are used for different purpose. So we are writing for M in Jane AI dot whatever the list of the models are there. We are writing the list of the models, and simply we are going to find what are the models that is used to generate the content. There are various types of models are there. So we are simply writing generate content, GENERAT, generate content, CONTENT. Whatever the models that is used to generate the content, I'm simply writing whatever the models that is used to generate the content in m dot supported dot generation method, and simply we are printing m. If we are going to check, these are the generative AI models are there. It is printing all the models. If you want to print only name, you can write m dot name. It will print you what are the name of the different generate content models are there. So you can use either the Gemini 1.5 Pro latest, Gemini 1.45 Pro 0.2, whatever the models you are planning to use, you can use it here. So I'm planning to use the Gemini 2.0 Flash. Okay, anything you can use, whatever the model you are planning to use, you can use it. But I'm planning to use one model called models equal to Jane AI dot generative AI. We are planning to use the generative AI. So we have to write the generative AI model, and which model I am planning to use, I am going to write clearly. I am planning to use the version called this one, models underscore Gemini 2.0 Flash. Okay, so any model, these are the various generative AI are there. You can use any models. Now our model is ready. If you want to ask any question, if for example, if I'm writing simple model dot generate content, and if you are going to ask any question, as for example, tell me something about machine learning, you can see, tell me something about machine learning. And if you are going to check, once it is done, if you are want to check what are the text it is generated, you can find it here. These are the text it is generated. Result, we have to write result dot text. You can see it is writing for whole about the machine learning. If you are going to ask any question, tell me something about VNR, VJIET. You can see, if you are asking this question, automatically it will go and check, and it will give you the output for VNR VJIT. You can see it is giving the VNR VJIT college. Even if you are going to asking some question, tell me something about Dr. Love, it will give you the idea about who is Dr. Love. Maybe it will not give you the right answer. If it is not giving the right answer, we have to write. Now you can see it is not giving the right answer, something like that. It is not giving the right answer. We are writing Dr. Love from NIT Kurukshetra, KUKSHETRA, Kurukshetra. Okay, you can see now it will give you the right answer. You can see it is giving the right answer. Yes, I found this one. It is from computer science department at NIT Kurukshetra. And what is the area of expert? It is giving all the, and something it also generated. If you are going to check, it is not giving the 100% right answer. Something it is also generated by their own idea, by their own experience. If I am working in the area of machine learning, mostly I can work with the medical science, something like that. So how they are finding based on the data. Okay, so it is not a searching technique, it is also generating the content. So what is the objective? Our objective is simple. What we have to write, model dot generate contents, and it will generate the content for you. It will generate the content for you. The same like that you can also write for OpenAI. This is for whatever the code we have written, that is for the Gemini. If we are going to check, we are using the Gemini 2.0 Flash. But if we are talking about the second one, the approach is simple. We can use the simple approach for, and the second one, how we can use the OpenAI. Same like that. From OpenAI, we have write from OpenAI import. We are working with OpenAI, and you can see we are using here client. Now you can see the syntax is little bit different. We have to write here response equal to whatever the response we are going to write. So we write client. Basically, little bit different syntax is there. It's client.chat. We are using the chatting system, so we have to write the client.chat compilation dot create. Then we have to write which models we are using here. So we are writing models equal to whatever the models we are using here. We are planning to use GPT-4 because I have the paid version. So I'm planning to use GPT-4. You can also write which users are there. You can also simple write the content here. If you are going to check, simply I'm writing the content here. So you have to write which users. As for example, I'm the user. Okay, and here we have to write the simple like that. There is also one syntax called temperature equal to 0. This is just like a syntax it is taking. So if you are going to check, we are writing the role equal to. So a content, here you have to write your prompt. Whatever the prompt you are asking, you have to write. So as for example, if you want to write, only you have to update this place. The rest of the syntax remain same. So now you can see, if I'm going to ask the same question, it will check and it will print the message. Just you can see what is the output we are getting here. Simple, we have to write response, response dot choice. It will basically, it will give you the different types of choice dot message dot message dot content. You can see it is giving like that. I'm not able to find the specific information related to this one. So you can see. So maybe some information is there, some info, but if you are going to check, only you can see. If you are using the Gemini, you can write model.generate content, and here you can write. If you are writing any question, as for example, if I'm going to write generate some job title similar to data science. Generate some job title similar to the data science. You can see it will work, and it will generate some job title similar to the data science. You can see it is working. Once it will complete it, it will generate some job title similar to the data science. You can see these are the job titles are similar to data scientist, something like that. Same like that, if you are going to ask the same question to the OpenAI, that is ChatGPT, only you have to write the same thing. There is no any difference, both are same, and automatically it will generate you what are the job title related to the data science. Okay, so it's working, and you can see these are the job title related to the data science. They have generated the 25 different job title related to the data science. But the question is how we can use for our analysis, how we can use for our scenario, how we can use for our scenario for sentiment analysis. So first I'm going to read the data. So we are reading the data called trade.clear. The same data I'm using, whatever the data I'm used previously. But if you are going to check how we are writing this value, if you are going to check generate some content, and here we are writing generate, and the same like that here we are writing the prompt here. This is also called the prompt. So now we are going to read the data, and it is not possible to work for all the data because it will take some time. So I'm planning to work for first 50 sample data. So what is the output we are getting for first 50 sample data? So we are writing here some sample data. We are taking data dot sample of 50. So we are writing some data sample. We are taking data underscore sample. We are not planning to work for all the data. We are working with first 50 data. So that's why we have written this one. Now we are going to reset the index for the sample data because randomly we are taking some 15 data. So we are writing data sample dot reset We are going to reset the index. Once we have reset the index, now what we are going to do like that, we are going to create one variable called data underscore sample called predict variable, and we are not giving any value to the predict value. If we are going to check like that, this is our data underscore sample. You can see this is our data underscore sample. So what we are writing here, we are writing what is our selected text, what is the sentiment, and what is the predict value, that is your null value. If you are going to check, this is the null value that we have to ask the generative AI to predict those value, Okay. Now we are going to generate the two samples, so that one sample we can use for Gemini and the second sample we are planning to use for the OpenAI, so that we can easily compare which one it is giving the better result. So now I am comparing here data sample 1 equal to data underscore sample dot copy, and the same like that we are writing data sample 2 equal to data underscore sample dot copy. Why we are writing this one? Because data sample 1 we are planning to use for Gen AI, and data sample 2 we are planning to use for OpenAI, so that we can do some fair comparison. So we have created here two samples. Once it is done, now we are going to take the JSON file, because we always get the data in the terms of JSON code. So we are writing here what is your JSON sample data. What is your JSON data you can write, or you can write the JSON sample data, because we always give the data in the terms of JSON format. So we are writing here data underscore sample 1, data underscore sample 1. We are only giving the selected text. What is your selected text? Selected text, and we are giving here predictive value. What is your predictive value? If you are going to check, this is your JSON file. In the JSON data, we are not giving any sentiment value. If you are going to check, the selected text equal to thanks and predict value equal to null. Selected text equal to happy friends, happy Friday, and predict value equal to null. If you are going to check, everywhere the predict value is coming null. We are only giving the selected text, because here we have given the selected text. We have already stored the sentiment value. Now we are going to write the prompt here. So I have already written the prompt for you. The simple prompt I have written for you. If you are going to check, this is the prompt I have written. This is very important, how we are writing the prompt here. So what we are writing here, even you can also generate this types of prompt by using the ChatGPT. You can also ask this one to generate the right prompt for predicting the sentiment analysis. So what we are writing, what is the sentiment of the following sentence? The possible sentiments are only positive and negative. You have to give the clear instruction. Okay. Now I'm saying, in your output, only return the JSON code back as output. Because if you are not writing, if you are going to check, in this case, they are returning the other value. They are returning why it is related to the data science. Okay, so here you can write, generate some similar title related to the data science. Here you can also write, don't explain, do not explain. You can also write, do not explain the rule. Do not explain the rule. If you are writing something like that, then maybe it will give you the right prediction. If you are going to check, now it is not explaining the results. It is only giving like that without any explanation. What are the titles are there? But if you are not writing, it will also give you the explanation why it is a positive sentence, why it is a negative sentence. So I have given the clear idea. No, I am not interested to know the explanation. Only you have to give what are the positive sentence and what are the negative sentence. So we have clearly mentioned, which is provided between the three dots. I have already mentioned where your data, this is provided between the three dots. Okay. Your task is to update the predicted value under the predict in the JSON code. I have clearly mentioned your task is only to update the predict value and don't make any changement in the JSON code. This is the prompt we have given. And if you are going to find what is your prompt, here you can see this is the prompt we are getting here. You can see it is giving the whole thing, and after that it is writing the data, whatever the data we have. Now we are going to write the same thing, whatever the content we have written here, the same thing I'm going to copy paste. CTRL C and CTRL And here we have to go past what is our prompt basically. PROMPT. Now we are going to execute and it will start working for all the application. At a time we cannot give more than 50. Even if your sentence is bigger sentence, we cannot give all the sentence, we can give 30 or something. So now you can see result dot text. If you are going to write, it will give you the idea. You can see now the predicted value is giving the output. You can see everywhere it is giving the what is your predicted value, negative or positive. Why not we have to convert this predicted value in your data frame format, and after that we have to write big. But if you are going to check, it is also writing this here JSON code, but the JSON code is present from here. So now we are going to write import JSON when import JSON file. We are going to import the JSON file, and then we are writing here data new. We are writing anything, you can write data new equal to JSON dot load. We are going to load the result dot text, but if you are going to check, the result dot text also contain JSON, so that is not required. So we are going to take from 8 to -3, something like that. We are going to check randomly. We are checking here, and then once it is done, we are writing the data in equal to pt dot data frame. We are going to convert to the data frame of data in. You can see this is your data in. This is your data in. You can see this is the predicted value, and what is your actual value? We can also write what is our ACTUL. Actual value is nothing but equal to that is present in data sample 1 of sentiment value. So now you can see, if you are going to check, it is giving both what is your actual value and what is the predicted value. If you are going to check data n, what is your actual value? This is your actual value, and predicted value is also positive. If you want to calculate what is the accuracy score, simple, we have to write accuracy score of data n of actual, comma this one. This is the accuracy score. You can see 100% we are getting the right prediction. 100%. If you are using the traditional method, if you are using the embedding method, you are getting the accuracy of 92%, but now you are getting the accuracy of 100%. Even you can also go for confusion matrix from sklearn dot matrix import confusion matrix, and you can print what is the confusion matrix look like. You can see there is no any misclassification here. There is no any misclassification. What procedure we have followed? Our procedure is very simple. We have written this prompt for you, and the prompt is the most important part for your generative AI. How good you are writing the prompt, that is the most important part. Okay, even you can also ask, you can also ask the generative AI to write the prompt for you. Even you can also ask here. You can see, even if I'm going to write here, write one prompt for sentiment analysis, it will also write the prompt for you. How we can write the prompt for sentiment analysis, it will also write for you. Okay, so now if you are going to accept it, you can see it is also writing, analyze the sentiment of the following are written only one word, positive or negative, and it is writing I am so happy, something like that. You can also write this type of prompt. Okay, so if you have no any idea, you can also generate the prompt by using this one. Okay, now we'll go for OpenAI. The same prompt I am also using for OpenAI. So again, I'm going to take the same prompt. What we have to take here? What is your JSON data? We are going to take for the sample number 2. This is your JSON data. And now I'm going to generate the same prompt I am using here, so that we will compare, we will do some fair comparison. We are using the same prompt. If you want to check what the prompt look like, the prompt is same, and here there is no any, if you are going to check, there is no any predicted value, still it's coming null. Now I'm going to use the same content, whatever the content we have used here. So now I'm going to write it. This is called OpenAI. In place of content, we have to write our prompt. PROMPT prompt. Okay. Once it is done, this is called the response, client.chat.response. Once it is done, we are going to use the same task, and it will give you the idea what is the output you are getting here. Okay, so now you can see it is working. Once it will done, we will also find what is our result value. Result is nothing but equal to response dot choice dot message dot contain, and you can see this is the value of results we are getting here. This is the value of results we are getting. Once it is done, we will also take the same code, whatever the code we are using here. Okay, so whatever the code we are in, now you can see it's already done and it is predicting, but here JSON file is not mentioned, so maybe it will start from 4 and it will go -5, something like that. This is your data in. No, so okay, no, we have to write only the result, not the result dot text. You can see the data n is ready. This is your data n for OpenAI. Now we are going to write what is your actual value. Actual value equal to data sample 2, and then we are going to calculate what is the accuracy score. What is the accuracy score for this one? So we are going to write what is the accuracy score for this one. This is the accuracy score we are getting here. Again, we are getting the 100%. If you want to find the confusion matrix, you can also check here confusion matrix. You can see. No, if you are using the user interface ChatGPT, both are same. Even you can also use the user interface ChatGPT. There is no any problem if you want to check. I'm also showing you how we can use the user interface ChatGPT. So this is your ChatGPT. Here you can also write like that. The same thing you will get. So just you can see ChatGPT. You can see here. You can also ask. Okay. You can also ask like that. So as for example, this is your data sample number 2. Now I'm going to shape the data underscore sample. Okay, sample number 2 dot something called dot 2 underscore CSV file. I'm going to shape the file and I'm going to ask the same question to the ChatGPT. You can see the same thing. You can use it. So I'm going to download the file. You can see this is the file we have. This is the file. Now I'm going to ask I'm going to remove this file and I'm going to ask the ChatGPT to predict the sentiments for every comment. So now we have to ask like that. You can see we are asking your task is to predict a sentiment for every comments present in every comments present in .csv file. I'm sharing .csv file and update regarding positive and negative sentiment in predict values. Okay, now it will ask you to give the values. Now I'm going to upload the file. This is your data sample number 2, and once I will give, okay, once I will give, it is also giving like that which type of model you are using. Once I have given, now it is going to analyze the data, and after that it will give you the output. So now you can see it is analyzing. You can see it is also giving the output like that. It is analyzing the data. Once it is done, it will give you the output. So now you can see it is analyzing the data. Okay, once it will done, it will give you the output. Yeah. So now you can see it has given this output. I have downloaded the output. I have downloaded the output, and you can see this is the output we are getting here. Again, I'm going to share my entire screen, and you can check what is the output we are getting here. So this is the output we are getting based on the generative AI. You can see it is also predicting those values. So either you can use the this one or you can use here. Both are almost same. Both are almost same. So there is no any difference between this one and this one. So again, I'm going to share my screen. Again, I'm going to repeat what procedure we have followed till now. If you are going to check it here, again, I'm going to repeat from here. So first I'm going to take in the GenAI. GenAI means generative AI, that is for the Google. And here we are using, there are different versions of generative AI that is basically used to generate the content. And you can use anyone. I'm using the Gemini 2.0 Flax. Okay, and after that, whatever the question you are asking, you have to ask based on this generative AI. You have to ask this question based on that generative AI. Okay, once it is done, then we are getting the result dot text. Basically, it will give you the output. Once it is done, now we are going to go for OpenAI. In the OpenAI, the syntax is different. You have to write like that which type of GPT model you are using. So I am using the GPT-4. And once it is done, after that you can ask the question. This is the answer. You will get it here. Once it is done, now we are going to work with the same data called train_claim. Once we are getting the data, we are working with the 50 sample. Okay, because if you are working with more number of sample, then you have to work in the terms of batch. You can directly, you cannot work. You can work in the terms of batch. That we will also see how we can work in the terms of batch. So that we will also see. But if you are going to check how it is working, here we are getting this value. Once it is done, now we are taking the same sample data. Here you can see we are getting the same sample data. Now you can see this is the JSON code we are getting here. Once we are generating the prompt, this is the values we are getting here. This is for prompt. Now we are generating the content. We are transferring to this value, and after that we are calculating what is the accuracy value we are getting here. Now we have taken the different sample data, and you can see the accuracy we are getting as 88%. You can see, and there are some samples that are misclassified if you are using this one. Same like that, if you are going for the OpenAI, now you can see for the different sample what is the output we are getting here. Now we are going to check for the different sample what is the output we are getting and how much accuracy we are getting. Because if you are using the previous one generative AI, you are getting 88%, and if you are using the OpenAI, now we are going to check how much accuracy you are getting here. So here also the accuracy is coming same thing. Accuracy is also coming 88%. I think accuracy is coming 88%. How it is coming 88%? You can see here also the accuracy is coming 88%. If your accuracy is not coming good, if you are not satisfied with the accuracy, you can also give some sample data, because if you are going to check, this is the common problem. Sentiment analysis is a very popular problem. Okay, so the OpenAI or ChatGPT can easily predict those values. But if you are working with some scenario and where the OpenAI had not that much idea, then in this case you can also give some example data. Okay, and that is also called one hotshot. That is also called multiple hit or one hit or multiple hit, something like that. So how we can give the example as an input? So as for example, if you are going to check here, the same thing I'm taking here, data example equal to data underscore sample, and I'm giving the 10 sample as a example, 10 sample as a example. So now we are going to write here data example dot reset, and here we are also, when we are generating this file, we are also generating the example file. So we write here JSON dot example equal to JSON dot example equal to data example. Then we are writing selected text, and we are giving the sentiments value. What is the sentiment behind this selected text? So we are writing here sentiment value. Just I'm going to check the spelling of this, your sentiments. So now we are giving what we are giving. If you are going for the example file, we are also giving the original sentiment, and here we have to write data example, where we have written this is your data example JSON. Okay, once we have taken this is your data example, and here we have to clearly write I am also giving some example for your reference. REFER reference. Okay, now we have to clearly write where the example is present. We have to clearly write it. So now I'm going to write the example file is present between 3 hash. We we are writing 3 has. And here we are going to write what is the example file. This is your example file we are writing, called JSON_example. So here you have to also give what is the example for this one. And after that, if you are going to check, here we are also giving some example, some idea how it is working. And now we will see what is the accuracy we are getting after giving some example. You can see now the accuracy got 100%. Okay, so some case if you are not getting the better result, you have to also give some example. You have to also give some example as a input. You have to also give some example as a input if you are not getting the better result. So if you are not getting the better result, then simply you have to give some example as a. So till now, if you have any question, then let me know. Anyway, any question. If you have any question till now, if you have any question, then let me know. Anyone.
Sir, there is a question posted by Virabhadra sir in chat box.
Okay, just I am checking. Just 1 second. Okay, so is there any difference between is there a difference on response using user interface ChatGPT, Gemini, and through coding like this? Okay, you can see there is no any difference between user interface ChatGPT, Gemini, and coding. But in the coding, you can also do some pre-processing. That is not possible in the case of user interface. So if you are using the user interface, simply you are giving the file, and this code, this model is going to identify the output for you. Okay. But if you are using the coding part, then the best part you can also do the pre-processing, and after pre-processing, you can give this data to the generative AI. Either you are using the chat GPT or either you are using the Gemini. Anyway, you can give this data. That is the benefit. Anyone, any other question? If you have any other question, please let me know. Anyone? Anyone? Any other question? Okay. So if you have no any other question, now I'm going for another part that is called the batch file. Okay, batch file. That is also very important concept. So now next one I'm going for batch data. Batch data. Because if you are using the coding, or even if you are using the user interface, at a time it will not work for the whole data. Here you can see we have given approximately how many data? 50 data. So at a time it will work for 50, 60, 70, but it will not work for more than 70 data. But if you are working with the sentiment analysis, and if you have the more data, or if you are working with any type of problem, and if you have the more data, how we can use the chat GPT, or how you can use the generative AI? Because I have mentioned, if you are going to check, I'm using some sample data. I'm not using the whole data. I'm using some sample data. If you are giving the whole data, as for example, if I'm giving 500, maybe this code will not work fine. You can see if I'm giving the whole 500, maybe this code will not give you the right prediction. Maybe this code will not give you the right prediction. It may be possible it will not give you the prediction for all the file at a time. So it will work for only the limited number of file. And that's why we have written here the value equal to 50. So here you can also generate. Here you can also use the concept called batch processing. You can also use the concept called batch. In terms of batch, basically we are going to predict those values. So now we'll see how we can make the batch and how we are going for predict those values. Okay. So if you are going to check, maybe I'm going to check how many files it is working, but that I have to check it here. If you are going to check, it is working in this scenario, it is working, but normally it will not work for all the file at a time. If you are working with the larger file, then we have to use the concept called batch data. So here we are going to make some batch of the file. So simple, we are making the batch equal to list, and you have to decide what is the size of the batch. So we are deciding the size of the batch. Size is nothing but equal to whatever the size you are going to take. We are taking the batch size equal to 50. Now, if you want to take all the data, you can simply write it here for I in range, whatever the data you have, you can write here to np.shape of data, and here you have to store the batch file. So what we are writing here, simple, we are writing this is the data we are taking, and we are taking the terms of different batch. If you are going to take it here, BSC TH, these are the batch file we are getting here. And if you are working with the zero batch, this is the data present in the zeroth number. You can see this is the data. If you want to find how many batches are there, you can also find it. This is the length of batch we have. This is the length of batch we have. So total 50 different batches are there, and each batch is total. Sorry, this is the file in the first one. If you are going to find the total 309 batches are there. So simple, you have to make how many batches you are going to make. Simple, you have to make this file. Now I am planning to work for only 2 or 3 batch. If you have the time, you can work for all the batch, but we are planning to work for only 2 and 3 batch. So now we are going to define one function. Simple, first we are also taking the time here. Import time, and we are going to define one function that will generate the content batch wise. So we are writing here define generate content. We have to write like that, content batch wise. It will basically use to generate content batch wise. Here we are going to find, we are going to return what is the batch basically we have. So batch, what is the current batch we are working with. We have to also write the what is the current batch, so that we can get the idea which batch we are working on. What is the current batch? What is the total number of batch we have? What is the total number of batch we have, and what is the models we are using? Which models we are using? Whether we are using the generative AI or whether we are using the open AI. So here we are also printing like that, so that we can get the idea we are working on current batch, CUR of current batch. We are working on current batch. Which batch we are working of? Batch of total batch, so that we can get the idea which batch we are working on, total batch. So what we have written here, the first line we are going to print the message which batch we are working. The first, what is our first objective? First we are going to make the JSON file, and based on the JSON file we will go for the prediction. So before that, first we have to write what we have to write. This is your data we have. This is the data we have. First we are going to make the data of predict equal to null, and then we are going to make the batch file. So data of predict, where we have written predict. After that we are making the batch, and then we are going to make the JSON data. The same thing we are going to follow here. The JSON data equal to, we are going to write here batch, whatever the batch we are passing here. In the batch, the first one, your selected text, we are going to write here selected text. Selected. Okay, better I have to do the copy paste here, whatever the contents we have written here. Selected text predict dot this one. This one. Once the data is ready, we are going to use the same prompt here. Whatever the prompt we have written here, the same prompt we are going to copy paste. So I'm using the same prompt here. The same prompt here, JSON data we have already defined. We are using the same prompt here. Once we are getting the prompt, now we are going to get the data. So we are going to generate the result. So our results equal to, we are getting here model dot generate content, and we are passing the prompt as a input. Prompt as a input. So whatever the prompts we have defined here, the same prompt we are passing the inputs. Once the result is ready, result equal to model dot generate text. Okay, so we are going to write it here. results equal to this one. Once the result is ready, model dot generate underscore content, we are going to read the same file, whatever the file we have written here. So we are in the file we have written here. This is the file I am going to take it. Yeah. So what we have done, like this is your prompt. We are writing. This is your prompt. This is your data in, and we are using the same code. Now we are generating the data frame. Once we have generated the data frame, if you want to print, you can also print what is the file of this data in. So we are also writing data in dot save, so that we can know like that whether it is working fine or it is not working fine. So if you are going to check what we have done, there is some problem which coming here. I think there is no any problem here. Results equal to model dot generate content. This one. After that, we are going to return the value. But before returning the value, we are also waiting for some time. So time dot slip, we are waiting for 5 seconds, and then we are going to return this value. So you can see. So what we have done like that, simple, we have designed one function called generate content batch. We are passing the batch as a data. We are passing which batch we are working on, what is the total number of batch we have, what is the models we are getting here. Okay. Once it is done, we are also going to print which batch we are working on, and after that we are writing the JSON data here. So now we are going to check whether it is working or not. So we are going to generate the result p equal to this one, and first we have to work for two batch. So we are writing for I in range of 0 to length of the batch. Instead of writing, we are writing here to batch. So we have to check there is some list has no object called to JSON. We have to check where we are doing the mistakes. So okay, so here we have to write batch. So now you can see it is start working. It is start working for the application, and once it will complete, it will give you the output. It is giving like that. I am working for batch 1 of 309. I'm working with the batch 1 of 309, and it is working here. So I'm not getting what is the value it is printing here. So maybe the data in dot save. We have to write the data in dot save instead of writing this one. So in this way, you can work for the different data. In this way, you can work for the different data. Once it is done, you can simply concatenate the value, and then you can find what is the output you are getting here. So if you are going to check, this is the output for the first batch. This is called the RESP of batch number 0, and this is the output for the second batch. You can easily find it which output we are getting for the first batch and which output we are getting for the second batch. So if you are working with the what I have mentioned, if you are working with the larger data, then you have to work in the terms of batch here. You have to work in the terms of batch here. Now the last one, we are going for the lang chain. If you want to develop some simple application, then you can also use the concept called lang chain. You can also use the concept called lang chain, and based on that, you can simply design some model. And what is the lang chain is like that? Based on the lang chain, you can also go for the prediction. So just you can design some simple application by using the concept called lang chain. Okay, so lang chain is just like one type of package that will allow you to create one simple type of application by writing few line of code. So just I'm going to check just 1 second. So So for the lang chain, these are the package for the lang chain. Just I'm going to write it here. And in this way, you have to write the value. So what we are going to do like that, simple, we are generating one prompt here by using the LangChain concept. What we are writing the chat prompt template from template and explain the concept of data science basic. And whatever the topic you are going to ask, this one will basically create one type of did not find the open API key. We have to check. Basically, the API key is not here. That's why this problem is coming here. So just 1 second. Yeah. So initially I have not given the OPI key, but once you have given the OPI key, after that your LangChain is ready. And after that, whatever the question you are going to ask, this is just like one type of prompt. And here, whatever the question you are asking, simply you have to write it here and it will give you the output for every question. So this one simple become one chat system. Even you can also ask the user. So as for example, we are asking like that, input, enter the topic name of a database. Once the user will enter the topic name directly, we are going for this one, and it automatically it will print the value. So if you are going to check, I'm asking about enter the topic name for database. I'm asking about something called primary attributes or whatever the data base. Even if I'm going to ask about the database, okay. So you can see it is giving the database is a collection of this one, something like that. It is giving. Even if you are going to check for other topics, simple, it is just like one type of chatting system. If you are going to ask any question directly, you have to ask it from here. So as for example, if I am asking about acid property, okay. So you can see acid property. It is giving for all the things. Acid means simple, atomicity, consistency, isolation, and durability. So if you are going to check, this is just like a simple command. It become your chat system. I have only written this prompt and it start working for the chat system. Okay, so here we are writing simple, explain the concept of database topic, and we are asking the user to enter which topic you are interested to know. Only you have to enter the topic, and after that it will start working for your application. So this concept is called the LangChain concept. This concept is called the LangChain. With simple 2 line of code, you can simply generate the value. If you are not writing the st.output parser, it will not generate the content in the right manner. Okay, so here we are generating the content in the right manner. Everything you can generate. As for example, if I am writing explain the concept of machine learning, we can simply write machine learning topic. Now this prompt become for machine learning. If you are going to ask any question like that, what do you mean by overfitting? What do you mean by overfitting? Now you can see it will check and it will give you the idea of overfitting in the machine learning. Refer to the scenario where the model performed extremely well on training data. Data it was untrained on but failed to realize on new or unseen data. So you can see in a single 2 line of code we have generated the whole. Okay. So again, I'm going to explain you from the starting point what we have done for this session. If you are going to check, I have already shared the code with you. If you need the data, I'm also going to share the data with you. But this code will work for all type of data. Initially, we have started with getting the open API key. I'm using the paid version. You can also use the free version. And for Google API, I'm using the free version. Then this code always you have tried. This is the code I have written for cleaning the text. When you are working with the text mining, automatically will write this code, because this code basically it will remove all the issue related to the text. Okay, so if any hyperlink is present inside the text, it will remove it. If any numbers are there, it will remove. If any stop words are there, it will remove it. After that, what we are taking also the embeddings of globe that we have already discussed. What is the embedding? Then I have given you the simple idea about the machine learning, how the machine learning is working, how the same model will work for all type of data. That is the motivation behind every company moving toward the machine learning. But if you are talking about the software engineering, if your requirement will change, your code will change. But here it is not like that. If your requirement will change, only your data will change, the code remains same. We are not going to modify even single character inside the code. Then after that, I have given you the idea about the TF IDF, how it will work for the TF IDF. Can we write the maximum feature in the TF IDF, or can we go for all feature? That we have already checked. There is no any benefit of getting all the feature. Once it is done, then we have also gone through the finding the what are the best set of feature by using the ransom test. Once it is done, then we are also going through the standard scalar, train and test split, and this one. After that, we are going through all the estimators, whatever the estimator possible inside whatever the estimator possible inside your scalar, you can use all the estimator, and we are getting the 35 different estimators. Now after that, we are going for all the estimator, and then we are finding which estimators are giving the best result, and we are getting the random forest classifier. But these are the step wise we are doing. You can also do in the single step by using the pipeline. And when we are making the pipeline, we are getting this type of pipeline. Here, pipeline is just like a sequence of the step. The first one, we are going to apply the clean text. Next one, we are going for the TF IDF. Next one, we are going for the function transfer. Next one, we are going for the standard scalar. And after that, we are going for logistic regression. And you can see once the model is trained, simple, you have to give your text, and automatically it will start working for your application. Okay. The same thing we have also start giving you with the respect to embedding technique. If you are using the embedding technique, what are the benefits you will get? And here we have also gone through the embedding technique. Then we are also making the pipeline for embedding technique. And once the pipeline is done, we have also gone through the generative AI content. Okay. In the generative AI, basically I have given you the idea about how it will work for the Gemini and OpenAI. Both code I have given you. If you are going through that, both the code I have given you. You can see this is the code. Then after that, we are also working with the sentiment analysis, but you can also work with any type of data. It is not like that you can only work with the sentiment analysis. If you are working with any text mining, simply you have to use this concept. Then after that, you can see predicted value. We are not giving the predicted value. We are asking the generative AI to predict those value, and after that we are comparing those value. If our result is not coming good, we are also giving some example sample data. Once it is done, now you can see we are getting the better accuracy, and after that we have also gone through the same approach by using the OpenAI. Once the OpenAI is done, then we have created one simple chat system by using the concept called LangChain. Okay, and only 2 or 3 line of code, and the whole concept is ready. The whole chatbot is ready. So done from my side. If you have any question, then let me know. Yes, definitely. This output totally depend upon the prompt. If you are giving the better prompt, definitely will get the better result. If you are working with some scenario and where you have no any idea about the prompt, you can also ask the generative AI to generate the prompt based on the whole PDF. You have to give the whole PDF, and then you have to ask the generative AI to generate the prompt for this PDF. It will also generate it. So generative AI totally depend upon the prompt, how good you are writing the prompt. And that example I have given you here. If you are going to check it here, if I am asking, I need code for, just you can see, I need code for sum of 2 numbers. You can see it is generate the code. If you are going to check, it is start working, and after that it will generate the code. This is the prompt I have given. I have not given the right prompt. Then you can see this one is taking the float. Now I will see like that. I want to take an integer as input. I want to take integer as an input, because initially you have not given the right prompt. Now it is start working, and even if you are going to check here, the Gemini is working here. Okay, so now you can see it modified the code. So why the first time it is not giving the right result? Because we have not given the right prompt. So prompt is very important in the case of generative AI. Anyone? Any other question? And even if you have checked, many times we are using the generative AI to fix the error, and it is successfully fixing the error. And you can see within a minute it is fixing. If you are talking about the normal process, if you are asking any developer, minimum it will take Minimum it will take 20 to 30 minutes time to find where you are doing the mistake. It will scan the whole code, and then after that it will find your mistake. But if you are using generative AI, within a minute you are getting the mistake. So access I have already given you. Yeah. Anyone, any other question? So done from my side. So if you have any question, let me know. If you have any feedback or comment, then you can also put inside the chat box. Okay, because this session I am mostly focused on the coding part, and due to
Sir,
the time,
one question
deep
from
learning.
my side,
Yeah,
sir.
yeah. Tell me.
Sir,
Hello. Yeah.
by using this Google Colab, can I find out different types of research paper for a particular subject, sir?
A different type of
A research paper for a particular
no.
subject.
No. We cannot, because this is just like a one type of Python platform. Instead of installing the Anaconda, simply we are using the Google Colab. We are not going to install any Anaconda in our server.
Yes, sir. Sir, only Google Colab, sir. Sir, I am not audible.
Yeah, sorry. So actually my connection got lost. Okay. Yeah. Anyone, any other question? If you have any question, let me know. I have already shared the code with you. The data also I'm going to share with you.
Yes, sir.
Yeah. Thank you.
Thank you, sir. Thank you so much for your session. A very good evening to all. On behalf of the Department of CSE, Cybersecurity and Data Science and AI&DS VNR-VJIT, I extend my sincere thanks to our expert, Professor Lav Kumar, Assistant Professor, NIT Kurukshetra, for today's enlightening session on NLP and Generative AI and Introduction to Agentic AI. Sir, you explained in depth about data preprocessing, word embedding, generative AI concepts, shapely values, LIME, artificial neural networks, and foundations of agentic AI. Your systematic and practical explanation have greatly enhanced our understanding of how these technologies form the backbone of modern AI systems. I also thank all the participants for your active involvement and enthusiasm. We look forward to your continued participation in the upcoming sessions. With this, we conclude today's session. Thank you once again, Professor Lav Kumar, sir, and thank you all for joining. Thank you, sir.
Yeah, thank you.
So thank you so much, sir. It's an excellent session, sir.
Yeah, thank you. So can I leave now?
Yes, sir. You can leave,
Yes,
sir.
sir. Yes, sir. Thank you so much, sir.
Thank you. Thank you.